soon. So without further ado, let us welcome Mr. Liew Sing Choy.
Yeah. Good morning. Good morning, everyone. Now, today I'll bring forward a concept called dimension. Now, dimension in physics and engineering, basically it relates to direction and length. It answers the question of how and where it's going. Now, to start off with, I have a piece of paper here. And this piece of paper is bounded by its boundary, where the edges separate this piece of paper with the surrounding area. That's all about it, it's a boundary. Now, from your view, there's actually a dot here in this piece of paper. This dot is bounded by the paper. Now, this dot is actually not going anywhere. It's isolated and it doesn't suggest it extends to whether left, right, up, or down. So what happened? A dot is called zero dimension because it doesn't tell of any direction, it doesn't tell of any length. What happened now is when I start to draw a line, I drag a line from this dot to your left by 2 inches. Now this is what you get, a line. I drag from a point to your left by 2 inches. Now you have 1 dimension, a line, 1D. Now things get a little bit more interesting now. Next, what happened is, I do not stop at 2 inches. What happened now is, from a dot, I extend a line until its boundary, where the boundary is separate the paper with the surrounding area. I extend this line until it reaches the boundary, and it bounces around the boundary. And in no time, what you will see is, you get an area where this piece of paper now is filled with lines, a black area, where you have width and length. And the product of it is called area, where length is being the longest distance. Now, by now you should have some idea what is meant by dimension, because dimension relates to distance and direction. Where would be the third dimension? Where this is the last dimension we'll talk about. Where's the 3D? Where would be the third dimension from here? Now, all you do is simple. I tie it off, and then I scrunch it into a paper ball. What happened now is your straight line, my previous straight line now, will be curved around and form the paper ball. And what happened now is, where's the third dimension? Thickness. Thickness will be the third dimension, where you have the area and extend from an area. And this is a 3 dimension. Now, this wraps up my dimension topic this morning. Thank you for listening.
Okay, Dr. Seng Choy, I'm going to ask a bit. Dr. Liew, yeah. I'm going to ask you a question which, well, relates to dimensions. Just follow along. If you go back to what you explained, where you've got 1 dimension, 2 dimension, 3 dimension.
0 dimension, 1 dimension.
Okay, 0 dimension, 1, 2. Is there a 4th and a 5th dimension?
Oh, that's a hard one now. There is. It's a very simple question, but it's a very, very complicated answer.
Okay.
There is a 4th dimension. 4th dimension we call a time-space continuum, where you include time. In classical physics, time is independent to location. But it comes from quantum physics that relates to 1, because the time that you have, the changes from your side, as an observer, as mine, the time changes is the same. But when the distance is far from here to universe, then you will have something called, the phenomenon called twin continuum. A paradox. What happened 1 hour there is 7 hours here. The gravitational is different when it relates to time and gravitational. So there's a 4th dimension. We don't go more than that. 4th dimension is something to do with subatomic level. We don't do it in real life. You can't talk it to 10-year-old kids. It's from 0, okay. 1, 2, 3. It's what you can tell, and people should understand better in that way, in that sense. Yes, I'm very tall.
It's a tall order for me to link it to how it works for society. I get the concept.
Yeah. Actually, we learn it in standard 3.
Yes.
We learn in area, we learn volume. It's just that we didn't introduce, we were not taught of that term.
Let me try it from another way.
Yeah.
Do you know Scarlett Johansson?
What's that?
The actress? The movie?
Okay.
Wait. Do you know that movie? No, not Black Widow. The movie where she increased the, Lucy, capacity of thinking, right?
Okay.
So, what Hollywood has done well is what Film Lab is trying to do.
All right.
Take high physics, science, chemistry, nuclear even, and make it into narrative that is popular. So you have one side of it, and I applaud you for using a simple gesture of the paper in your hands to really put a separate track to highlight physically that we can see to the points that you're making. But I just wish that that final bridge is, why should we care about it? How does it help us in our daily life? That's the only missing link for me. So again, I would like to come back next year if I'm invited again and see you at that part. And I think it can do wonders. For example, if we are in Penang, the Penang Bridge, the lines and dimensions and whatever else, you know, the tall buildings that we have, KLCC, how does it impact us not just scientifically, but maybe even emotionally? Because dimensions and lines and spaces, they do affect our emotions and thinking. Thank you. That's just my 2 cents worth.
Right, thank you. Claire, I think you have something to say. Yeah.
See, I can't even work the microphone. That's how. Yeah, I think I would just echo what Suhaimi said and really reinforce that. I mean, it was a really good presentation, of the concept.
Thank you.
You know, I could see you were very nervous, and I think you need to relax into it a little bit. I know it's hard to. We keep saying have fun in this competition, and it's very hard when you're standing there being judged to have fun. But I think you had fun with the presentation. Absolutely. It wasn't, you know, you brought it alive, and I think so. I was very engaged from the time that you got up there. You involved the audience. I understand dimension. Yes, thank you. But I don't. But it's a little bit like being in, you know, in a school class. So, you know, I understand it, but then how am I ever going to use this in real life? So it would be good if you could start with that, hook your audience, rather than maybe start with a concept. So and then you bring it back round. So that's how we know, you know, we build bridges or whatever.
All right. Thank you.
Exactly what Claire just said.
Okay. Okay, thank you, Dr. Liew,
Yes.
for your presentation.